Okay, let's talk about section 3.7, implicit functions. So we said we had to solve something as an implicit function if we can't get y alone on either side of the equation. And there are several examples here. But one way to find derivatives of implicit functions, is to try to solve for y and then compute the derivative. But that's not always easy. But let's do it both ways here on number 1. If we solve this implicitly, we're always solving it with respect to x. Okay? So we're going to look at the derivative of 3y, which is 3. Then the derivative of y with respect to x. I'm going to say minus the derivative of this is 12. The derivative of x with respect to x, which is just 1. And the derivative of 6, which is 0. Okay? So what this looks like is 3 dy dx minus 12 equals 0. 3 dy dx equals 12. And then if I divide both sides by 3, dy dx equals 4. Well, let's take this same equation, and in this case we can solve this for y, can't we? So 3y equals 12, whoops, that's an x, 12x plus 6. We'll divide everything by 3. Y equals 4x plus 2. Now, the derivative of y with respect to x equals 4. We got the same answer. So implicit differentiation is definitely a tool to use when we cannot get y by itself. Alright, so unfortunately it's not always convenient or possible to solve for y. So we are going to take this and find dy dx. Alright, so x squared plus y squared equals 16. We want to take the derivative with respect to x. So this will be 2x dx, which is 1, plus 2y dy dx equals 0, right? So let's subtract 2y dy dx, subtracting 2x from each side. Then I'm going to divide by 2y, right? So really, dy dx equals negative 2x over 2y. So it says sketch 4 tangents to the circle, 1 in each quadrant, and see if it works. See if you get what you're looking for here. Okay? So, let's look in quadrant 1. In quadrant 1, your x and y are positive, right? So if I take that dy dx, it's going to be negative 2 times a positive number divided by a positive number. It's going to be a negative number. So the slope of that line should be negative, and it is in quadrant 1. Okay? Quadrant 2. X is negative, y is positive. So it's negative 2 times a negative over a positive. Should be a positive, and sure enough, in quadrant 2, that slope is positive. Quadrant 3. X is negative, y is negative, so negative 2 times a negative over a negative should be a negative, and sure enough, in quadrant 3, that's a negative slope. And finally, quadrant 4, let's see, x is positive, y is negative, so negative 2 positive over negative equals a positive. And yes, the slope of that line is positive. So our result makes complete sense in this case. Like I said, implicit differentiation is a good tool. All right, now it says show analytically that the derivatives at these points are 0. Well, first of all, we have to find the derivative of this equation and then plug the points in, right? So let's see, we have 5x to the 4th plus y squared equals 9. And again, we're finding the derivative with respect to x, aren't we? So first it's 20x dx over dx, which is 1, plus 2y dy dx equals 0. Derivative of 9 is 0. So 2y dy dx equals negative 20x, right? Divide by 2y dy dx. I'm going to simplify as negative 10x divided by y. All right, so let's look at 0, 3. If we plug x of 0 and y of 3 in, we get negative 10, 0 over 3, which is 0. That's what we wanted to show. Do the same thing here. Negative 10 times 0 over negative 3 equals 0. Let's see, 0, 3. Now that makes sense, right? That's where the lines, those are horizontal lines which have a slope of 0. So it makes complete sense. All right. Find the equation of the tangent line to this curve at this point. Now we've done this with quadratics and everything else, haven't we? We have to find the slope at this point, and that's found by taking the derivative and plugging that point in. So let's do this. Again, derivative with respect to x. So that would be 2x. All right, now I have to do a product rule here, don't I? The derivative of x is 1 times, so f prime g plus g prime plus f times g prime, which is 2y dy dx equals minus 2 dy dx. Now I have to distribute this negative sign, don't I? So this becomes 2x minus y squared minus 2xy dy dx equals negative 2 dy dx. I need to put all the dy dx terms together. So I'm going to add this term over. 2x minus y squared equals 2xy dy dx minus 2 dy dx. Let's factor out the dy dx. 2xy minus 2 dy dx equals 2x minus y squared. These get a little bit crazy. So I'm divided by 2xy minus 2. So I now know that dy dx equals 2x minus y squared over 2xy minus 2. Let's evaluate this at the point 2, negative 1. All right, so 2 times 2 minus negative 1 squared over 2 times negative 1 minus 2. So my numerator is 4 minus 1 is 3. This is going to be my slope, right? This is 2 times 2 is 4. Negative 4 minus 2 is negative 6. So notice my slope is negative 1/2, isn't it? So we are going to take that slope in this point. So I start with y equals mx plus b. Y is negative 1. The slope is negative 1/2 times the x, which is 2, plus b. Negative 1/2 times 2 is negative 1. Negative 1 equals negative 1 plus b. Add 1, b equals 0. So my equation then is y equals negative 1/2 x. Okay? Let's move on to the last thing. Now it says determine the coordinates of the points at which the tangent lines to the curve are vertical or horizontal. So when they're vertical, that means the slope is undefined. If they're horizontal, that means the slope is 0, right? So let's take the derivative of this with respect to x. So 5y to the 4th dy dx minus 1 dy dx equals dx equals 1, right? The derivative of x with respect to x is 1. I'm going to factor out dy dx. 5y to the 4th minus 1 equals 1. So So dy dx equals 1 over 5y to the 4th minus 1. Now, there is really no way that we can get this derivative to equal 0. So it can't be 0. So no horizontal tangents, right? But guess what? We can get this thing to be undefined by finding where this denominator is 0. So let's do this. Y to the 4th equals 1, y to the 4th equals 1/5. So if I took the derivative, the 4th root of this, I end up with y equaling plus or minus 0.668740305. The points we're looking for are right here and right here. So what I did was I took this original equation and I plugged in y and I figured out what x was. And these are the points I came up with. When x is 0.535, which makes sense here, y is going to be negative 0.668740305, and then x will be negative when the y is positive. So we just have to remember, as always, when you take the derivative, that's the slope at a certain point. You can always plug points in. In this case, we wanted to know where that derivative was 0 and where that derivative was undefined. And it could never be 0. And if you look at this, there's no place where we have any horizontal tangents, but we definitely have 2 vertical tangents. Okay, so this is the end of the implicit differentiation video. Let me know if you have any questions.